So using Newton's law of cooling, we come up with this differential equation of dT in terms of temperature over dt in terms of time is equal to K times the ambient temperature minus our temperature that we got the derivative of. Okay, so there's three parts that we're going to analyze in this video. A, which is let V equal dt dt, and take the derivative of both sides with respect to t, and then rewrite the answer in terms of V and dV dt. The second part asks what form must V equal V of t have to have. And then the last part is, now that we know what that form is, use our differential equation up here to find some, to make sure we have a differential equation that satisfies the general form of t equals t of t. So let's first start off with A up here. And so we have another way of just writing dt dt is just starting off with V. So I'm just going to say V equals K T ambient minus T temperature that changes with respect to time. All right, so now we want to take the derivative of both sides. Derivative of V is dV dt. K times, because it's constant, so T ambient, we said that's a constant, so that's 0, minus the derivative of T is dt dt, or V. So dV dt is equal to negative KV. Don't forget about that negative sign. Bam. So that's A. So now earlier in the section we talked about a theorem that said if we're given f prime of x is equal to k f of x, then f of x is equal to c e to the negative kx. Okay, so using that, we're going to find the form of v of t, which is, you can say v of t is equal to, matching up this with this, we don't want to forget about the negative sign because the k is the constant, so we have c e to the negative k, and then because this is with respect to t instead of x, negative k t. So this is b. This is the form we're looking for. All right, so then the last part is we want to find the general form of t equals t of t. So the way we do that is, well, we knew this was equal to v, and we knew this was equal to v. So c e to the negative kt is equal to k t ambient minus t with respect to t. So now we want to isolate this t, because it's the same t of t that we were talking about. So first we're going to multiply out the k. So we have k t ambient minus kt. All right, so now we want, as I said, isolate the t. Subtract k t amb from both sides. So I'm just going to rearrange the order a little bit. So negative kt equals c e to the negative k lowercase t minus k uppercase t ambient. And then we're going to divide both sides by negative k. So t of t is equal to, and I'm going to switch these around because when we divide by the negative, this would become negative and this will be positive, so just switch those around. So negative k divided by negative k is just t ambient minus this constant over a different constant, so we have minus c over k e to the negative kt. So that's our answer.